This is Greg Troutline with Maritime Reporter TV, and we're very pleased to be joined today by Bill Wetta, the CTO of DSC Dredge, to discuss dredging tech trends in general and the recently delivered Marlin class CSD Vaneta Marine. So, Bill, it's great to catch up with you again. And while I'm sure that most watching this know the DSC Dredge name, why don't you give a short overview of the company, its capabilities, and a by the numbers look at the company today?
Sure. So DSC is a family-owned dredge manufacturer. We employ almost 300 employees and probably 50 plus contractors, especially during this Vaneta Marine contract that we're working through now. My dad started a company that became DSC back in the 70s, but my brother and I have basically been running the company since the 90s. And just to give you an idea kind of where the dredging space is right now, before we did this, I was going through the list of what we have under construction. We've got 4 mining dredges that are all US based, 5 navigational dredges under construction, 4 of which are international, 7 reclamation dredges under construction, 6 of which are international, 3 contracted general construction dredges, which are all domestic, a number of upgrades for our legacy equipment and other competitors' legacy equipment, and basically a workload that's active all the way through 2027.
As you know better than I, the dredging market in and around the US has been on a bull run for many years and counting. When you look at your business today and you look down the road, say 5 years or so, what do you see?
So two big things jump out. One, everyone is concerned with safety and risk. So there's a big push to either eliminate or reduce the number of people involved around a dredge and on a dredge, which leads to automated technology and robotic technology. And everyone is very, very concerned about making the planet greener and more efficient. And there's a big change moving away from traditional fuels to more electric systems, hybrid systems, or just much cleaner burning fuel systems.
As I mentioned at the outset, we are here primarily to discuss the new dredge, Vaneta Marie, which was recently delivered to Muddy Water Dredging. And in the press announcing the unit, you said, and I quote, this dredge represents the future of dredging technology. Now, that certainly is a definitive statement. And I'd like you to take as much time as you like because I love talking about the technology angle here. But can you discuss in detail the outstanding technologies and systems that are built into this unit on which you're sitting right now that make it the future of dredging technology?
Sure. So the Vaneta Marie was specifically built for a certain set of projects in the Gulf Coast area, primarily the Calcasieu River, although it will actually bid work from Galveston all the way to Pensacola. Most of the contract dredges, if not all that operate in the United States now, are basically were either built as a copy of something or built originally not as a dredge and converted to a dredge. So not built for specific tasks. The market for this dredge is a market where we're doing mostly navigational maintenance type work, where material is not really that deep, but it tends to be more in the corners of the channel, where movement becomes really, really important. And not just the throughput of the dredge, but how fast it can actually step. So to start with, we met with the client that owns this dredge, and they wanted to be able to dig depths to the new Panamax ships. So this dredge can dig pretty deep, so it can actually dig container ports that went as deep as Panamax vessels. They wanted the machine very green, so the machine incorporates the latest Tier 4 diesel engines that are available on market that do not require any diesel exhaust fluid system. So they're green right out the box without any add-ons. The dredge also, because it's diesel electric, can take power from the grid. So this machine could run strictly off of an umbilical cord. It's also designed because we're in a hurricane area where we can export the power off these engines in a disaster event, and we can actually power a city or a plant. So it's basically an 8 megawatt power plant that becomes a dredge. The engines, like I mentioned, were Tier 4 finals. The dredge is very ergonomic and spacious, very simple to operate. The operator operates the whole dredge with basically 8 buttons. Um, there's not a lot of fancy joysticks and controls. The screen that he operates from will flip screens as he activates controls. So he's only looking at the function on the dredge that's being operated at the time. It's got the fastest swinging and stepping capability of any dredge in North America. So it can move from left to right extremely fast, and it can reposition on its carriage extremely fast. It incorporates an underwater pump and a carriage on the back, which both are basically scored as additions for Corps of Engineers contracts. So Muddy Water will get actually a bonus on a contract because of the underwater pump and because of the carriage. It's got a sanitation system on it that can treat sewage and drop it overboard, but it can also go in areas where there's no overboard dumping at all, and it can hold that with tanks for quite an extended period of time. So it can basically be a zero emissions vessel as well. A lot of the controls on it, like the ladder up and down, there's redundant winches on it. So if a cable were to break in the middle of a ship channel, the dredge could still operate and function with a single winch. The fuel system is redundant. It actually has a redundant engine, a main engine in place. So it operates, it has three big Wabtec gensets. It typically would only operate on two. It's got all of the hydraulic systems. If a series of pumps go down, there's another series of pumps that can kick on. The gland water systems and the freshwater systems are the same way. So it's basically self-sufficient other than if something happened to the dredge pumps. The control system is, like I mentioned earlier, is very simple. And it can be remotely viewed or remotely controlled. This dredge has full cellular connectivity and Starlink connectivity. So pretty much anywhere in the world, you can view the cameras, the dredge control system, the history, and basically take control of the machine if you'd like to, if you've given permission. The dredge has 72 tanks, void tanks on it. Each void tank is monitored for water level or fluid level. So if the dredge ever did get hit or have a problem, you would know immediately that a tank had a problem. All of the equipment on this dredge is mounted above deck. So there's nothing below deck as far as other than the storage for the sewage and fuel. So really there's no bilge area in the dredge that could ever cause a sinking or anything, but all these tanks are monitored, and the insurance companies give them a benefit, a reduced rate because of that. The dredge has full production monitoring. It includes all the DSC benchmarking tools. It's got quite a bit of room for future expansion, and it incorporates our DSC Vision and Dredge RX systems.
I guess, we talk about technology relentlessly in all that we do in online, in print, wherever you may find us. How does all this technology, what does this equate for the user of this dredge? I mean, what kind of efficiencies are they going to gain from this cumulative tech that DSC Dredge delivered?
There's a lot of computers on the dredge, and for traditional dredge operators, that can be scary. But when you sit in the chair of the dredge, there's basically 2 screens and 8 buttons. One screen looks like a video game, and that's DSC Vision, and it's basically cartoonishly rendering the dredge with what the bottom looks like in a 3D colored map. And the other side of the simple gauges that the operator looks at to control the dredge. So the operator doesn't have to be aware of everything around him. Everything's pretty much handled with the automation system. He doesn't have to look for auxiliary systems. It's monitoring all of that in the background. If there is a problem, he'll be notified and the chief engineer will be notified. So he doesn't have to do that. The swing speed is automated on the dredge. The cutter speed is automated on the dredge. The dilution control is automated. The dredge pump speed is automated. And then as the dredge goes online and starts working a few jobs, we'll automate the stepping time, the carriage time, the depth, the swing direction will all be automated as well. So we're making it where the operator really needs to just focus on production. He doesn't have to focus on a bunch of auxiliary things. So we're thinking that that's going to make it very, very productive.
To follow up on a bit, I know we had discussed the Wabtec engines, in brief, but Obviously, as we discussed at the outset, the maritime sector is facing the reduction in emission mandate. Can you discuss why the Wabtec engines were chosen for this installation?
So these are the only engines in this class that can be Tier 4 finaled and don't have to have a bunch of post-treatment or diesel exhaust fluid added to make them meet Tier 4. Looking at the exhaust, it's pretty clear. You don't get any black smoking at all with the engines. It sips fuel compared to some of the higher speed engines. Very, very fuel efficient. And really, we've run this engine before on a Port of New Orleans dredge, 2 cylinders smaller, and it's been running for years and actually been very, very productive. So we've got really good experience with the Wabtec engines and really, really pleased with the emissions that we're getting out of it.
So, so again, we're here now with Patrick Webb, Senior Director of Global Sales, Marine and Stationary with Wabtec. Patrick, over the years, I've become increasingly familiar with the Wabtec brand and its growth in the maritime and the offshore sectors, specifically your engines that meet EPA Tier 4 final emission standards without the use of urea. Can you please tell us a little bit about the Wabtec power units, specifically that are installed on the Vaneta Marine?
Yeah, we're real proud to be involved with Muddy Waters and that fantastic state-of-the-art dredge vessel. Really, what they put together is going to set new standards, I believe, for suction head dredges in the U.S. I think what a lot of customers are going to find is that that kind of efficiency that they're operating at is going to be something that's going to put them first in a lot of bid processes. But back in 2015, we took our first order for Tier 4. That was with the Oceaneering Evolution vessel that we powered, a light construction vessel. And that since then, we have had about 24 different applications that we've provided engines for. Heavy on the dredge and construction side, really proud of all of our hopper dredges that we're providing power to, and suction heads like the Vaneta Maria, and also even clam bucket dredges. And so the draw, I believe, as I look at it, to not have urea in an engine gives more space, gives more flexibility for the operators, but also it's the logistics. And so what we found with our engines not requiring any after treatment, no DEF, no urea, that makes every operation have less logistics demands, less hassles for pumping, for transporting the urea, less need for keeping heated and cooled during hot and cold climates. And then a little unknown fact about the Wabtec Tier 4 engine is that the opacity of our exhaust, the actual density of and darkness of the exhaust that comes out of those engines is so light, so clear, that it really has set a new standard for emission, and the way it looks when a dredge is operating in a port or go away. So on the saving side, on the logistics side, on the clean environmental cleanliness side, all those things have really caused a project like the Vaneta Marie with Muddy Waters to really align very well with our Tier 4 engines.
With some of the tech that you already discussed, but I know particularly that the DSC Vision in particular was a really unique, innovative package that you developed. So can we take a little bit deeper dive into the DSC Vision and the Dredge RX remote monitoring system? Just give me a little, I guess, a little more how it walks and talks and what it enables the operator to do.
Sure. So the DSC Vision system is basically an onboard multi-beam sonar. So DSC Vision is a multi-beam sonar that's attached to the dredge, and sonars typically don't really work unless there's movement. So what's been done in the past is there's been rotator arms put on, or actually you run a boat around the dredge, but we actually use the motion of the dredge to create the motion for the sonar. So we're actually looking at a line basically perpendicular to the center of the dredge, maybe 100 feet or 30 or so meters forward of where the cutter head is, and all the way back behind where the ladder pivots at the trunnion. And we look at that line, and as the dredge pivots from left to right, that line becomes a plane, and it paints what the bottom looks like. So when an operator shows up on a core job, let's say, before they even start digging, they can make a pass to the left and a pass to the right. And basically they can see everything on the bottom real time that's in front of them and behind them. And they know if the job that they're going on even resembles what the plan was. And then as they start digging, it's real time updating so they can see the changes they're making in the channel bottom. They can also see what's caving in and behind them. So if the dredge advanced 100 feet and the whole bank caved in, they would be able to see that real time, back up and fix that rather than having to wait for a survey crew to come on board.
I guess given all that we've discussed with the incredible technology that's built on this, it sounds a little silly to ask what's next, but in the "what have you done for me lately" society in which we live, I guess big picture today, what are the drivers that you're seeing in the dredging market that will power DSC into the future? And in your role as CTO, where do you see even more efficiency or cost savings that can be gained?
So broadly speaking, on the mining sector, which is mostly not navigational, they're mostly in inland ponds. I don't think past the year 2025 we'll build a dredge that requires a human. I would imagine that all of those machines will be fully robotic. And that's both from a safety concern and a productivity concern. You can't quite do that on a navigational job where you have ship traffic and boat traffic, but the systems are going to become more and more automated. I think you're going to see more diesel electric machines that can run off the grid. And then eventually you'll see systems that are running ammonia or methanol or even hydrogen to reduce emissions even further.